Hi there, Ms. Lambs here. In this video, we're going to show you ANOVA and Post-hoc using SPSS. Just want to let you know we make this PowerPoint and videos around June 2022. Just want a disclaimer saying that I'm not expert in statistics, so just some very brief general guidance. So please feel free to research further. So most of the content from this PowerPoint is based on this link below, and I'll put the link in the video description below. So IB Profile will keep learning and updating. So if you have followed my channel, you will have noticed that previously I've made an ANOVA and Post-hoc video using Excel. However, we found out that actually Excel is not it's not adequate, okay, to cover both ANOVA and Post-hoc. So therefore, hence this video. So we have a new PowerPoint video on this to show you how we conduct the ANOVA and Post-hoc test using this new software called SPSS. And I would like to say a big thank you to my colleagues, Dr. Kuan and also Ms. Rawat for the guidance on this PowerPoint. So let's add on, and here we go. So you will also notice there will be some slide that's common. I just want to briefly introduce what is ANOVA. So when do we use it and how we use it? Okay. So this is a flow chart explaining how it works. So for example, if your experiment have the independent variable is discontinuous and have more than 2 items, in this case, e.g. antibacterial effect from water, lemongrass, and pandan essential oil. Okay, so because you have more than 2 items, so therefore you run an ANOVA test. So an ANOVA test is a test that will run a comparison all in one go. And at the end of the ANOVA test, you will obtain a p-values. And if your p-value is greater than 0.05, then you will accept the null hypothesis, meaning that amongst all the comparison pair, there's no significant difference between all the IVs. Now, however, if you run the ANOVA test and turns out your p-value is much smaller than 0.05, then you will reject the null hypothesis. And then that means that amongst all the comparison group, for example, water compared with lemongrass, water compared with pandan, and lemongrass compared with pandan, at least one of these comparison pair has significant differences. So in order to find out which comparison pair has significant differences, you will run the tricky post-hoc test to find out which comparison pair has a significant difference. And at the end, you will obtain p-values for all these comparison pairs. And if the p-values is smaller than 0.05, then you will reject the null hypothesis. Just one thing though, p-value is always in small letter. Okay, so this one actually is small p-values. Okay, so next one. Why do we do ANOVA and Post-hoc? So we want to minimize what we call a type 1 error. Okay, so some students will ask, oh, how come we don't just run multiple t-tests? Because every time when you run a t-test, there could be some error, and this error could build up. So we will increase what we call a type 1 error, and type 1 error is just reject the null hypothesis when it should have been accepted. So again, there will be some reference here. So I will put this link in the video description below, so we can look for it, research it a little bit more. All right, so we just mentioned about the flowchart of how it works. Just want to add one thing is that if your p-value is really, really small, you can be even more confident of your statistic test. So for example, let's say if your p-value is even smaller than 0.01, then you can claim that the p is smaller than 0.01 and it's at 1% significance level. This means that 99% not due to chance that amongst the group, at least the comparison pair has a significant difference. Okay, so that's the idea. All right, so how do we do the SPSS software? So here is the website, and you can register it, and then you can download the software. Now, just bear in mind that this software has a 1-month free subscription trial, so you can use it wisely. All you need is just an email, okay, and then set up the account. So this will be what it looks like. Okay, so how do we use the SPSS software? So in the Excel, okay, you should have set up the data when you were collecting data, right? So for example, this is the IV, okay, and then you have done 10 trials here, and then this is the result, okay? So for example, this water, this is lemongrass, and that is pandan, okay? Now in the SPSS, okay, you will notice there's 2 tabs, okay? And data field and also variable field. Now, what we will look at the variable field is how you set up the, for example, the header in the data field. Okay, and afterwards, then after we have input the data, then we will analyze using the SPSS software. Okay, so we go to the variable tab, okay, the second one, and then we need to adjust the header, okay, so header of the table. So here, for the first one, is the IV, okay, type your name here. So e.g., for example, essential oil. Now, there's a limitation in this software, so they don't allow space bar. So what you can do is you can type essential and then underscore oil, okay, then that would be fine. And also you need to make sure that the type is numeric, okay, so yes, right, okay. And the next one you need to look into is the values. So you need to define what is meant by the values. So input the names of your IV. So 1 represent water, okay, 2 represent lemongrass, 3 represent panda, okay, so just add onto it, okay. All right, so later when you type the letter 1, oh no, sorry, number, if you later type on the number 1, it represents water. And if you type number 2, it represents lemongrass. And you type letter 3, okay, no, sorry, number 3, then it represents panda. Okay, and make sure this type is numeric. Okay, the second row, okay, you can type in the DV name now, quantity count. All right, so then after you've done that, then you can go back to the header, you can go back to the data view tab, okay. And when you type, you will see that, okay, so the first column will be essential oil, and second column will be quantity count. Okay, so then what you do is you just type the word one, okay, type 1, and then automatically it will change to the word water. And then if you type 2, it will change into lemongrass and so on. Okay, and then in the second column in the quantity count, you can just simply copy from the Excel, okay, and then it will automatically be there. Okay, so after a while, then you will have something like this after you've input all the data, okay, and then you go for the analyze, okay, go for compare mean, and then go for one-way ANOVA. Okay, then this window will pop up. Then you need to refine which one is the dependent list and which one is the factor. So very simply, click on the essential oil, click onto this one, and then this is the click on the essential oil, click on the factors. Okay, so that's your IV, and click on the quantity count, go to this one, and that will put it into the dependent list. Okay, and then so you will get a dependent list is quantity count, and the factor, your IV, is essential oil, and then just press OK. And then this small window will pop up, so it will show you the one-way ANOVA. Okay, so how do we report the ANOVA? Okay, so you need to mention that, explain to the reader that, oh, how many comparison group are there, okay, and then within groups how many trials, basically. Okay, so then you type F, okay, and then bracket 227, okay, so just degree of freedom, okay, so go for here, equals 8.064, okay, so that's the F values, okay, and then comma, and then P equals to whatever value, that's the surveillance values, okay, 0.002, okay. Now this one is actually smaller than 0.01, so that means that at 1% surveillance levels, that means at 99%, not due to chance that the three sets of data, amongst the three sets of data, at least one of the comparison pair is significantly different. So therefore, we need to find out which comparison pair is significantly different. So we run the 2-key post-hoc test to find out which one. Again, it's very simple. So from the same set of data, okay, you go to the one-way ANOVA. You have just put the dependent list and the IV here, right? So then instead of pressing OK, you just go for a post-hoc. And then a small window will pop up. So you just click 2-key, and then you just refine this significance level to 0.05. And then a window will pop up, and then you can scroll and find the post-hoc test here for multiple comparison. And this one will tell you which comparison pair and the significance levels. So here you can see that water and lemongrass, the significance level is 0.770. So this is actually bigger than 0.05. So therefore, you will accept the null hypothesis. So there's no significant difference between water and lemongrass. And then comparing water and pandan, okay, you can see that it's 0.013, so that is smaller than 0.05. So you will reject the null hypothesis, and at 5% certain levels, okay, you are 95% not due to chance that this happens. Okay, there's a certain difference between water and pandan. And then if you compare lemongrass and pandan, this one is even smaller, so it's 0.002. So this one you can use at 1% confident, and then it's 99% not due to chance. Okay, this happens. Okay, so okay, yeah. All right, so there's a summary. Okay, so water versus lemongrass, you quote what is the p-value, and then mention that since it's bigger than 0.05, there's no certain difference between this set of data. And then water versus pandan, there's a certain difference at 5% certain levels. And then lemongrass versus pandan, you can see that even smaller p-values. So you can say that as 1% certain levels, that there is a certain difference. Okay, so yeah, just report your p-value as usual, mentioning the fact that whether there's a certain difference between the two sets of data. And that's about it. Okay, so I hope you will find this video useful. At all, and bye for now.